All right, what's up guys? In this video, we're going to pick up some calculus here. We're going to do another integration practice video. So we're going to evaluate the integral of the square root of 9 minus x squared dx. So for this integral, I would use a trig substitution. And if you notice, what we have here is we have the square root of a squared minus x squared. And we know that if we have that, then that means that x is going to be equal to a sine theta. So in our case, since we're given the square root 9 minus x squared, then that means that x is going to be equal to 3 sine theta. Okay, we now need dx, so let's get that. So dx is the derivative of x. That's going to be 3 cosine theta multiplied by d theta. Okay, next thing is to set the integral up, and then we'll have the square root, and we'll have 9 minus, we'll stick in our 3 sine theta, and then don't forget that that's being squared. We'll then multiply by dx, which was 3 cosine theta, and then d theta. Okay, so that's where you should be once you have set it up. Now, in my videos, I don't skip steps. I like to go over absolutely every step in my videos because I don't want to leave anyone out or lose anyone. So you could probably end up skipping a lot of these steps. And when I say skipping these steps, meaning that you don't have to write them all down when you're doing a test or a quiz or something like that. You can kind of shorthand a lot of this stuff, but I'm doing it for the purposes of the video, so that's the reasoning. So in this case, we got 9 minus, and then let's simplify. So we'll get 9 sine squared theta. So I can break this up as the square root of 9 times the square root of 1 minus sine squared theta. So we know that this is just going to end up giving us 3 times the square root. Remember, cosine squared theta is going to be equal to 1 minus sine squared theta, because remember the Pythagorean identity that sine squared of theta plus cosine squared of theta is equal to 1. So if I solve for cosine squared of theta, I'll get 1 minus sine squared of theta. So this would be cosine squared of theta. Take the square root of all of that, then I'll get 3. This is absolute value cosine of theta, and we can go ahead and drop absolute value bars, and then we'll just get 3 times cosine theta once you simplify. And so when we do the integral, what we're going to end up having is 3 times 3, which is 9. That can come out front. And then I'll have cosine times cosine, and with respect to theta, obviously, and this would be cosine squared theta, and then d theta. So that's where you should be once you've gotten through the simplification part for the square root. The next thing is to use some identities here. So remember, cosine squared theta, that's just going to end up being 1 plus cosine of 2 theta all over 2. So I'm going to end up factoring out a 1/2. And remember, that's a half angle identity. And then on the inside here, I'm just going to have 1 plus cosine of 2 theta. And we're going to integrate that with respect to theta. Okay, so let's go ahead and do that. So we'll get 9 over 2, or 9/2. And if we integrate respect to theta over here, we'll get theta. And this will be plus 1/2 sine of 2 theta. And this will be plus c. Now I can use a double angle identity for sine of 2 theta. So this is going to be 9 over 2, and this will be theta, and this will be plus 1/2. Remember, sine of 2 theta, I can write that as 2 sine theta times cosine theta, and then again tackle on a plus c at the end here. And as you can see, the 2's would just cancel out. Okay, now what we're going to go ahead and do now is we're going to go back to our original substitution, which was x is equal to 3 sine theta. So what we'll need to do is we'll need to solve this for sine theta and solve it for theta. So if we solve it for sine theta, we'll get sine theta is equal to x over 3. And if we solve it for the angle theta, then we'll get theta is equal to sine to the negative first, or arc sine of x over 3. That's what we would get. Okay. Now, let's continue. Now we know that we need sine theta. So hopefully you guys remember SOHCAHTOA. Remember, sine is opposite over hypotenuse. And when we solved for sine theta already, we already got that was going to be x over 3, which means that the opposite side is x, the hypotenuse is 3. But don't forget that we need cosine theta as well. Remember, cosine theta, that's adjacent over hypotenuse. Okay. Now, we know what the hypotenuse is, but we don't know what the adjacent side is. So what you want to do in this case is find the adjacent side, and we can do that using Pythagorean theorem. So that's going to be a squared plus b squared is equal to c squared. We already know what the opposite side is. We already know what the hypotenuse is. So we basically need to solve this equation for b to find the adjacent side. So in this case, since the opposite side is x, if I square it, then I'll get x squared. This will be plus b squared. 3 squared is 9, so this will be 9. I solve this equation for b squared. I'll get b squared is equal to 9 minus x squared. And then if I take the square root of both sides to solve for b, I'll simply get b is equal to the square root of 9 minus x squared. And that's going to be my adjacent side. And so now I got sine theta. Again, that's x over 3. And now we have cosine theta. So cosine theta is going to be the square root of 9 minus x squared all over the hypotenuse, which we know is 3. Okay, so if you want to visualize this a little better, you can just draw a triangle. And we know what the opposite side is, that's x. We know the adjacent side, or excuse me, the hypotenuse is 3, and the adjacent side down here is going to be the square root of 9 minus x squared. So if we go back and we remember what we had 9 over 2, or 9 halves. Now remember, we went ahead and solved for theta at the beginning here. We solved for theta and we got sine to the negative first of x over 3. Or arc sine of x over 3. Okay, and then it's going to be plus x over 3 multiplied by the square root of 9 minus x squared all over 3. And then plus c. Okay, now we can go ahead and simplify this side a little bit. So we'll get 9 over 2. This would be sine to the negative first, x over 3. We know that 3 times 3 is 9, so we could effectively end up writing this as plus x times the square root of 9 minus x squared all over 9, and then plus c. Okay, now I'm going to go ahead and distribute in the 9 halves and kind of simplify a little bit, and when I do that, I can go ahead and write my final answer right after I do that, so we'll go ahead and do it. Alright, so if I distribute in the 9 halves, I'll end up with 9 halves times sine to the negative first of x over 3. When I distribute in the 9 halves here, you can imagine that this is 9 halves multiplied by x times the square root of 9 minus x squared, all divided by 9, which would just basically end up reducing down to x over 2. I'm going to pull out a 1/2. I'll tackle my x, and then I'll multiply that by the square root of 9 minus x squared, and then I need to tackle on a c to my answer, and that is your solution. So let me circle that for you. And that is how you evaluate this integral using trig substitution. Alright, so if you have any questions about how I got my answer, I'll be more than happy to talk about it with you. So, alright, so I will see you guys next time.